All right, let's dive into something pretty wild today. We're going to explore a radical what-if scenario that came out of some cybersecurity research. It's a thought experiment that really pushes the limits of what we think is possible with these massive global satellite networks. And it all hangs on this one fascinating question. Could you actually weaponize a satellite network without it even knowing? We're not talking about some sci-fi hacking of the satellite itself. No, we're talking about turning it into an unwitting pawn in a much bigger game. So, how on earth would that even work? Well, the core idea is to think of it not as a weapon made of explosives, but a weapon made of mirrors. It's all about a kind of cosmic geometry. The official name for this is a reflected signal attack, and the concept, when you break it down, is surprisingly simple. You'd have an attacker on the ground with hundreds of transmitters. They'd shoot signals up, bounce them off the metal bodies of satellites just passing by, and then time all those reflections perfectly so they all land on and totally overwhelm one single target back on Earth. Let's walk through it. The plan is basically 3 stages. First, transmit. Hundreds of ground stations just fire signals straight up into the sky. Second, reflect. Those signals hit satellites whizzing by and just bounce off. And third, the really tricky part, converge. With almost unbelievable timing, all those scattered, reflected signals are calculated to arrive at one specific spot at the exact same instant. But, and this is a huge but, as elegant as that all sounds, the theory immediately slams headfirst into a massive wall, and that wall is made of the fundamental laws of physics. So here's problem number 1. A normal satellite link, that's a one-way street, right? Ground to satellite. But for this reflected attack, the signal has to go all the way up, bounce off something, and then travel all the way back down. It's literally a round trip. And that round trip has a devastating cost. We're talking about a signal loss of around 110 decibels. Now, to put that number in perspective, that makes the reflected signal 100 billion times weaker. It's basically indistinguishable from background static at that point. It's just noise. So yeah, the expert analysis from the source material is pretty clear. The whole idea is, and I quote, technically infeasible. It's a non-starter. Case closed, right? The physics just doesn't work? Well, not quite. This is where the thought experiment gets really interesting. What if the attacker isn't playing by the normal rules? What if they have a completely different playbook? Let's just call it the God mode scenario. So to make this work, we have to start with some pretty wild assumptions. Imagine the attacker controls the company that builds the satellites. They could build them to be perfect, steerable mirrors. Now, give them unlimited supercomputing power and a massive network of transmitters on the ground. All of a sudden, those insurmountable physics problems, they start to look a little less insurmountable. Okay, but even with God mode, you solve the signal strength problem, but another, way more subtle issue pops up. It's not about how loud the signal is anymore. It's about its shape. Let's call it the lock and key problem. Think of it like this. A legitimate signal from a satellite is like a perfectly cut key. It has a very specific shape, its phase, its polarization, its timing. The receiver on the ground, that's the lock, and it's built to only accept that one perfect key. The problem is, the simple act of bouncing a signal off a metal object flying through space physically distorts it. It warps the key. The receiver's hardware is designed to see that warped key as just junk and reject it. So once again, the attack is dead in the water. A warped key can't open the lock. End of story. Unless we add one final and honestly pretty chilling piece to this whole puzzle, the blueprint for the ultimate backdoor. And this is the question that makes the entire theory finally snap into focus. What if the lock itself, that receiver terminal on the ground, was deliberately built with a secret flaw? What if the lock was built to fail? And that's how you get the perfect storm blueprint. This is where it all comes together. Step 1, you manufacture satellites to be perfect mirrors. 2, you use supercomputers to plot those impossible reflection paths. 3, you transmit from a huge ground network. And then, the final crucial steps. 4, you engineer every single receiver terminal with a secret firmware backdoor. And 5, that backdoor tells the terminal to accept that corrupted, warped signal as if it were legitimate data. You see, this whole thought experiment, it isn't really just about satellites or signals. It's a story about the ultimate supply chain attack. It forces us to question the fundamental trust we place in our technology. And it leaves us with this one final, unsettling question to chew on. What does it mean when the varied tools we build have secret capabilities that we can't even see?